Hey everyone, it's me, Miss B, and in this video we are looking at the Unit 6, Lesson 7, Cumulative Practice Problems for Illustrative Math Algebra 1. So we're going to start with filling out this table. So it says for our instructions, complete the table while showing all your work. So I am going to use a calculator for some of this, but I'm going to show you how I'm finding each of these numbers, just so that you can, I'm fulfilling that show all of my work part. So let's read our question here. Based on past musical productions, a theater predicts selling 400 minus 8p tickets. So just to clarify what they mean here, this entire expression is the number of tickets. That's how many they expect to sell when each ticket is sold at P dollars. So P is the price, and depending on that price affects how many tickets they'll sell. Generally, people will buy more tickets if they're cheap and less tickets if they're more expensive. So that's the relationship that they've come up with. So we want to complete the table to find out how many tickets they want to sell, or they expect to sell, and then what revenue it expects to receive at the given ticket prices. So I'm going to highlight this word here, revenue. Revenue is kind of a vocab word. This means money they would be making. How much money will they make if they sell them for these prices? So when we start off with number of tickets sold, that is talking to us about number of tickets sold. That's going to be our 400 minus 8p. That's where that's going to come from, because they said that's how many tickets. So I am going to have 400 minus 8 times 5. And 8 times 5 is 40. 400 minus 40 is 360. I am not going to show where I plug in for every single group of tickets here, but we will just show that for the first one so that we can say, like, hey, I know what I'm doing. So 400, now if we did 8 times 10, that would be 400 minus 80, and that would be 320 tickets. 400 times, or minus 8 times 15 is going to give us 280. If we do 400 minus 8 times 20, we'll get 240. And you might be able to see a pattern here. This seems to be going down by 40 tickets every time I go up by 5. But now, in the next jump, we're going to go by 10. So it should probably go down by 80. But still, we're going to plug it in. 400 minus 8 times 30. This gives us, 160. So it does go down by 80 instead of 40. 400 minus 8 times 45 will be 40. And then 400 minus 8 times 50 is going to be 0. Because 8 times 50 is 400, so just be like 400 minus 400. So down here at the bottom, it says P. Well, if they sold P number of tickets, we were just plugging it in, so it's 400 minus 8P. All we're doing is writing that expression. Now, how can we figure out how much money they're going to make? Well, the amount of money you make is based on how many things you sell and at what price. Good thing is we have both of those numbers here. So revenue is going to be price multiplied by the number of tickets. So in this case, we would say 5 times 360. And so the revenue they can expect to make is 1800 or 1800 or 1800. That's how much money they could expect to make. And we're going to follow that pattern here, multiplying them across. 15 times 280 gives us 4,200. 20 times 240 would be 4,800. 30 times 160, also 4,800. And for the last row, 0 times anything is 0. So even if it's 0 times 50, it is still 0 money they would make because they're not selling any tickets. But what am I doing here if I'm writing this in terms of P and 400 minus 8P? Then what goes in this box is the price multiplied by the number of tickets, which is 400 minus 8P. Excuse me. Okay, so they're now asking us, once we have this table full of values, for which ticket prices will the theater earn no revenue? So that means they are going to make $0. And we want to explain how we know. Well, that is going to be our right-hand column. And I see one place where they would be earning $0 of revenue. That is right here. And that ticket price, if we look over to our left, that is the $50. So they would earn no revenue if they sold tickets for $50. Now, there's one more on here that I would say we could be a technicality, but it's not on our table. So I'm going to put this in parentheses, and I'm going to say, or for $0. And I guess at that point, I'm saying it's a technicality because then they're not really selling them. They're giving them away, but they're not earning any money from it because they're not collecting any money. So that's another possible thing is if their ticket price was $0, they might sell a bunch of tickets. According to their equation, they'd sell 400 tickets, but not make any money off of it. So then that brings us to part C. For what or at what ticket prices should the theater sell its tickets? Okay, so I'm going to highlight some pieces here of what they're asking. So at what ticket prices? So this is what they're asking. They want a ticket price. Should the theater sell the tickets? If they have to earn, so I'm going to say must earn at least 3,200 in revenue. That's one of the conditions to break even. And breaking even just means to not lose money on the musical production. Because it costs money to put on a show. They have to, do the costumes, the sets, probably pay the actors maybe, and they don't want to lose money. So our big number that we're focusing on here is 3,200. And if we look at our table, we want to find potentially all of our numbers that are greater than, they said, well, at least 3,200. So equal to 3,200 is okay. So 3,200, I see right here in revenue, that one's fine. 4,200, that one works. 4,800, these ones work. But then I have down here $1,800. That's not enough money. So based on our table, and that's how I'm going to phrase my answer, I would say based on the table, they should sell tickets for $10 to, and the last one that worked was 30. So I'm going to say $10 to $30 each. Because they said what ticket prices, that was potentially multiple, so I'm giving a range. They should sell their tickets for $10 to $30 each. That is question 1. Question 2, we're switching it up a little bit. This is more of our pattern stuff. It's a little different than some of the patterns of boxes that we've seen before. So the way I describe these box patterns to my students is that if we see a square and that square in our pattern is growing in both the length and the width, then it's increasing its size in length and width, and that means that we have a quadratic function. But I definitely have 3 rectangles here. They are not the same size. The trick to seeing this one is splitting it into 2 different pieces. So I am going to highlight one of these squares in step 1 green. If I just looked at the green square, it's the bottom half, and really, I'm going to highlight the bottom half of all 3 steps. And I think this will be a little easier to see. Now that I have a green square and a white square, I have a green square that goes from being 1 by 1 to now being 2 by 2 and 3 by 3. I also have a white square that's 1 by 1, a white square that's 2 by 2, and a white square that is 3 by 3. So I have quadratic patterns here. It just so happens that I have 2 of them going on at the same time. So when we have 2 of those things happening, that just means we're going to add a coefficient here. So they're asking us to write an equation to represent the relationship between the step number for n and the number of small squares as y. So I can say the number of small squares is, and if it was just the white squares or just the green squares, I'd be able to say that that's n squared. But in this case, I have 2 sets of them, so it's going to be 2n squared. And you can check this by plugging in 1, plugging in 2, and plugging in 3, and I promise it works out. Now, the second part of this, part B, says, is the relationship between the step number and the number of small squares quadratic? So basically, is this quadratic? And then explain how you know. Well, it's still quadratic. Even if I have 2 quadratic patterns happening at once, it doesn't mean they're not. So I would say yes. Yes, because, and instead of using the picture as my guide here, I'm actually just going to refer to the equation that I wrote. And I'm going to say yes because the equation contains n squared. And as long as it has n squared in it, that means that it is quadratic. And that's it for question 2. So this homework assignment, again, is only 1 page front and back, so we're going to be on to the back side of this page. We have 3 questions here. For number 4, we will use graphing technology, so I will switch over to my graphing calculator and we'll look at that one. But first, let's look at question 3. Function f represents the revenue in dollars. So another revenue question, that's money that we are earning. Revenue in dollars, so this is money earned or made, that a school can expect to receive if it sells, they're giving us another expression here. This is a number of coffee mugs for X dollars each. And so this expression is going to be important. So this is just like if we had a graph of the ticket price problem from the front side of the page. But instead of selling tickets, we're selling coffee mugs. And this is how much money they could make if they sold this many coffee mugs. So we're going to select all statements that describe the situation. So first off, we have here at $2 per coffee mug, revenue will be $1.96. Well, our price and our revenue is on our graph, so we're going to read that from our graph. At $2, the revenue, that doesn't look anywhere near 196 to me. This looks like 400. So I'm going to say no on this one. It's got to be closer to 400. B, the school expects to sell 160 mugs if the price is $5 each. Can I read that from my graph? Well, my graph contains revenue and price. It doesn't contain the number of mugs. But what does contain the number of mugs is this equation, because that equation represents the number of coffee mugs they would sell. So we're going to work this out over to the side. If it's $5 each, that's X. So we're going to do 220 minus 12 times 5, or 220 minus 60, and that is 160. So this is an answer. This is true. Now let's look at C. C says the school will lose money if it sells the mugs for more than $10 each. So let's look at now losing money. That's the amount of money they're making. So that is something we can look at on our graph. And then $10 each, that price, that's another thing from our graph. So $10 each, if we follow that up here, this is not really what I would consider losing money. After this, yes, the amount of money they earn goes down, but it's still not losing money. Losing money would be where it's like negative. So I would say that this one is not true. There's actually another statement in here that kind of applies to the idea of they really should sell them for around $10 and not less. But let's keep going just in order. The school earns about $1,000 if it sells the mugs for $10 each. So $10 each. Is the school earning about $1,000? Looks like it's around 1,000 to me. Right over here. It's pretty close. So since it says about $1,000, we're going to say, yep, that one is the correct answer as well. For part E, the revenue, so the money they earn, will be more than 700. So we're looking at 700 on our revenue. That is right here on my graph. I'm going to follow that line horizontally. So that way we can see what might be above it. Because above that is going to be more than 700 and below that will be less. And then the price is between $4 and $14. So they're talking about $4 and about $14. I'm going to put some vertical lines here so that I can see more of what I'm talking about. And so when they say that the price is in between those, it does look to be pretty accurate that yes, they will earn more than $700. It does appear that this entire part between these two halves is above this little line right here. So that means yes, they would earn more than $700 if they sold things in this price range. So E, also true. Now the very last one, that's what I was talking about earlier, is that the expected revenue will increase if the price per mug is greater than $10. Now this is not necessarily true. If this said decrease, I would agree. And so after $10, the price is going to go down and the revenue would decrease, but they're not necessarily losing money. But since this is increase, we are going to say no, that is not an answer. But if they said decrease, that would be more accurate. So the correct answers here for this one are B, D, and E. That brings us then to question 4, which we are going to use some technology for. So we have a marshmallow launched straight up into the air and with a slingshot. So they're giving us a function h using the equation h of t equals 5 plus 20t minus 5t squared. So I like to always highlight my functions. This describes the height of the marshmallow. So height of the marshmallow, not how far it fell, the height, as a function of time since it was launched. So use graphing technology to graph the function h. That's going to be 5 plus 20t minus 5t squared. Now I'm going to pull up Desmos and graph this to answer some of these questions. That is when for the maximum. When does the maximum happen? So let's look at our questions here first a little bit. When, so that's time, does it reach its maximum height? How long is also an amount of time before the marshmallow hits the ground? This is when height is 0. And then what domain makes sense for the function in this? So that's what x values should we be using or looking at. So time for it to hit the ground. Okay, I want to make sure that I get this right. So we're going to open up Desmos graphing calculator here. The difference here is, though, Desmos does not play super nice when I use a variable that is not x or y. So for this function, instead of using t, I'm going to type in x. That's the only difference you can really see here. So 5 plus 20x minus 5x squared. All right, so we can't really see it. But if you're doing this on your Chromebook, you have a touch screen, and I'm filming this on a tablet, which is definitely touch screen. So I am going to pinch my y-axis, and what that will do is squish my graph down to where I can see the top of it. And then if I spread my fingers out kind of diagonally, that'll help me zoom in and see everything here. And yeah, so now I have some appropriate information that I can see from this graph. So the first question they asked me was, when does this reach its maximum height? And so that is that part of your curve right at the tip top. So let me actually show this point here, this maximum. And actually, Desmos is kind enough that it places a dot there when we select the function. And so I can see that the x value, which is time in our case, is 2. So if we go back and using our graph, we can answer about when does the marshmallow reach its maximum height? We can say at about 2 seconds. Now we want to answer how long does it take before the marshmallow hits the ground, and we said that height was 0. So for that height to be 0, over here, that is going to be down here at the bottom, this other point on the right-hand side. Because if the height is 0, it's on the ground. So that's 4.236. But you'll notice I also have another spot where it might hit the ground, and that's negative 0.236. That one does not make as much sense because the marshmallow did not necessarily start on the ground. We'll talk about that in a minute when we talk about the domain question. So we're going to say at about 4.2 seconds, or you can say more specifically 4.236. I'm going to say about 4.2 seconds. And then they said, what domain makes sense for the function in this situation? So that means which x values or horizontal values make sense. And I did just talk about how this negative time doesn't really make sense. We should probably start right when that marshmallow gets launched. So for us, that is going to be at 0. So I can move the negative part off of my graph and just go from where I kind of have 0. But I also want to include where my marshmallow hits the ground. If I zoomed this out, it doesn't really make more sense. You'll notice that my parabola, after it hits the ground here, it keeps going further down. And that would mean that this marshmallow is falling through the ground and eventually, I don't know, probably going to hit the core of the planet. And that's not actually the case, and that's not actually what happens. So when we're talking about which domains make sense, we only want to go from 0 to about 4.2. This is the only part of the graph that we're really going to look at, and that's really going to matter. So that's what they mean by domain. So let's write a domain here, and that's going to be using t as our variable. So on the far left end, we would have from 0, and it's okay for it to be equal to them because that's where our graph would start. So we have our time. And then I'm going to be specific and say 4.236 in terms of seconds. That domain makes sense in this situation because of the context. And that's question 4. Question 5 is really just choosing between two options and then explaining how we know, and then we're done. So let's read this one together, and we'll go over which one we should choose. So a rock is dropped from a bridge over a river. So it is dropped from a bridge over a river. Which graph could represent the distance fallen? So representing the distance fallen in feet as a function of time in seconds. So we're looking at, is this amount going to start low and increase? Is it going to start at 0 and then go up? Or is it going to start here and then go down? And since this is the distance that it has fallen and not the height of the rock, we should be starting at 0, 0. Because the instant you might let go of that rock from your hand, it hasn't moved. And as soon as time passes, then it starts moving, and the distance it's fallen will increase as time goes on. If it was height above the water, then we would do this one. So we're going to choose, for this question, we will choose A, because the distance fallen will start at 0 and then increase. And I'm going to write a little note on this one that this would be like height of the rock, not distance fallen. And that's it. So there was only 5 questions on this homework assignment, although they were kind of complicated with some of the revenue things. Hopefully my explanations made a bit of sense, and if they didn't, please always ask your teacher in class and maybe even go to tutorial. So thanks for sticking with me through this video. This has been the Unit 6, Lesson 7 cumulative practice problems for illustrative math, Algebra 1.